to myself.
Yeah, that's all I heard.
I know. Like.
They're so funny. There's like bonus. It's like bone and there's like.
Sometimes when I hear the announcements and they say the same thing like 17 times in a row, I'm like, seriously, why do you say the same thing 17 times in a row?
What?
They ask for the question. It's like, do you have a desire to do this? It's like, no one's gonna answer that.
I like today when Zane was like, do you want to get up and personal with the Colts players?
Oh, I know what he's talking about, yeah. And then he just like, yeah, he's like, I love that.
Yeah, I like the Merry Christmas.
It was just like a big pause. Merry Christmas! And then like he like turned the page. It was pretty funny. So anyway.
There's no good way to do that. It's like you flip it over and you're like, you don't want to be the first person, like the first announcement, like Merry Christmas, and then it sounds completely weird.
Yeah, especially in November 5th. When we talk about inverse functions, right? Inverse function is what undoes a function. So the inverse of addition is subtraction, and the inverse of multiplication is division, and the inverse of x squared or squaring something is square rooting, and the inverse of an exponential function is a logarithm.
What is that? What is this?
Is that it? What is that?
I just put a divided by a sign. That's much. That is beautiful.
This is really just to kind of show you why we do logarithm functions. It's not just a random thing they throw in. It's because that's how we solve exponential functions. That's how we undo them. Okay? So what is a logarithm? I kind of took stuff out here to make you fill in the blanks again. Well, I didn't draw the line like your church bulletin. But if x is bigger than 0 and a is bigger than 0 but not equal to 1, those are all the if parts, then if you have an equation y equals log a of x, that's how we say that, base a, log a of x, the a's little, that is true if and only if you could write that as a to the y equals x. So notice the base of the logarithm becomes the base of the number. The answer is the exponent, and this x is what a to the y is. So you have to make sure you know where all those things are. This is how I can make you do logarithms without a calculator, because I can give you ones that work out exactly, where you can rewrite it using the definition of a logarithm. That's what we're going to call this.
And most calculators only go up 1%.
Well, not if you have one of those fancy calculators. That's why I just don't allow any calculators. Them fancy Casios and Texas Instrument Plus.
Like flip it up and like do the.
Yes, there's other ways. You're getting ahead of me. We're not there yet. Today is just definition of a logarithm. So the big thing to remember is a logarithm is not a brand new operation. A logarithm, the answer to a logarithm is just what is the exponent that makes that true. So a logarithm is just an exponent. Right? I should have made that a blank that you had to fill in.
Instead you put it on caps.
It's very important. A logarithm is an exponent. A logarithm is an exponent. A logarithm is an exponent. There could be a question on your test that says a logarithm is a blank, and you can put torture and awful.
Should be a logarithm.
Did we learn this in Algebra 2? Or am I just remembering?
You did. A whole chapter of it in Algebra 2, which means hopefully it's not so bad. So I'm pretty sure all of your homework today says evaluate the logarithm. That means I want you to do that without a calculator. If you have a fancy calculator that does logs of other bases, I don't want you using that on those questions. If you remember how to change the base, I don't want you using that on this test, because when we have the actual test, you will have a no calculator portion of that test. And the majority of that no calculator portion of the test will involve evaluating logarithms like this. So if you use your calculator on your homework, you're not preparing for the test, which counts way more than homework, right? Right.
Pretty much, yeah.
So all you have to do to evaluate this is think about what it means. If you don't need to rewrite it, you don't need to rewrite it. But you should be able to say, this is the base, like 2 to the what, I wrote f of x there, but we could change it to y, equals 64. That's what that's asking. And you might say, oh my gosh, how am I supposed to do that without a calculator? But it's just 2's. You can do that, right? You could just keep thinking like powers of 2, 2 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64. I think it's 6, right?
Yeah, I could have done that.
You could. You just keep multiplying it out, right? You just write it out. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. And then you count how many 2's you have. 1, 2, 3, 4, 5, 6. So the answer here is just 6. The answer is what exponent makes that true. You just have to remember how to rewrite it. Because if you remember how to rewrite it, it's just, some arithmetic.
I like this.
So what about this? Log 7 of 1. 7 to the what power equals 1? So now let's get a little crazier. I don't know why we are typing things in our calculator, children.
Checking.
10 to the what power equals 1 over 100. That's the big thing you have to remember, what to rewrite. This is the base, this is the answer, you're trying to find the exponent.
-10. Never mind.
The hard part, and some of the ones on your homework today are really tricky with the exponents and the fractions. If I see this side is a fraction and this side isn't, automatically I'm thinking that we're going to need a negative exponent. Do you agree with that? And so we need to think about what power of 10 is going to equal 100? 2. But if I just wrote 10 squared, is that true?
No.
No, it would have to be 10 to the negative 2. You with me on that? You use your calculator, so don't act like you.
I'll use it after just to check it.
That's good.
So you don't have to show a lot of work on these, but sometimes it's helpful too. Like you could have rewritten this as 10 to the what equals, you could have wrote that as 100 to the negative 1, and then you could have wrote it as 10 squared, but I'm not going to do that yet. We'll wait for later for that. Number 4, I just want to caution you to be careful on this, because a lot of people on number 4 are going to say 2, because you see 25 and you see 5, and you think 5 squared is 25. But make sure you remember this is your base. So this is like saying 25 to the what power equals 5. How can I write a power here that's going to make this a smaller number? Yeah, when you are taking like a root, a square root, a cube root, a fourth root, remember that that's the same as a fractional exponent. So this is the same as saying 25 to the 1/2, because 1/2 is a square root. So a couple big ideas here. If your base is not a fraction and this is a fraction, you're going to need a negative exponent, because that's how we move stuff across the fraction bar. If your base is bigger than this, like a root, then you're going to have to need a fractional answer. And a lot of times people mix these up, so make sure you kind of think about it. It's not bad to write off that one step. We also can use our calculator, and when we have the calculator portion of this test, there will be questions that just say evaluate. If you have a fancy calculator, you need to be really careful about what you use, because you probably have a button that lets you plug in the base of a log. But on most calculators, regular calculator, when you have a button that says log of x, this is called the common log, because when you just see log of x, that's the same as saying log base 10 of x. Why do you think base 10 is the common log that we use? Why don't we have base 7 log?
That's a good number.
Metrics.
10 is what our number system is based on, right? Like that's our number system. When I write a number 324, I'm using base 10. This is my ones, this is my tens, this is my hundreds, right? We're base 10 number system, so that's why common log is base 10. I thought you said you weren't coming second hour. Colin, I feel like I've defeated you in life.
Colin! Yeah, you put me down a couple times. Hi, Colin.
It does nothing.
Colin, don't let her face me.
I feel like it was all SFA's fault.
I think it's your fault. 184509304.
Please calculate. When we take the portion of the test. Well, we'll see. I might make you use on my calculator. Anybody have a calculator? Oh, we're kind of prepared to throw at you.
I'll catch one, just hand it over to somebody else. Catch next year. You grab them all. How you want that? I did one. No, I gave my calculator away. Wow, that was not, yeah, think of that. Not good.
Again, during a test, I will not help you use your calculator, but before a test, I will help you. But all you have to do on my calculators is you hit log and then the number and you type it in. And let's go to 3 decimal places.
So is this going to be 2 separate things?
Yeah, probably. We'll see. The no calculator part shouldn't really take very long, but I think I've just given up in the past of trying to do it all in one day.
Domain error. Domain error.
And think what that's saying. Log 7 is saying 10 to the what power equals 7, so that's why it's a number less than 1. 10 to the what power equals 0.042, that's why it's a negative. But what happens when you do -2? Log of -2 is like saying 10 to the what power equals -2. And your calculator will say domain error because is there ever an exponent you can plug in there that will give you a negative number out of here?
No, it's undefined.
Yeah, there's no answer there, which means when I give you a question like this, it's probably going to be on a no calculator part of the test because I don't want your calculator to tell you the answer. I want you to know you cannot take the log of a negative number. You can't even take the log of 0 because there's no exponent that will ever give you 0. That's why we have the horizontal asymptote. So don't write domain error. You should write like no.
Domain. I just wrote undefined.
Undefined, that works also. Oh, I'm really hot.
It's pretty warm.
Yeah, it's
What?
getting hot in here.
Oh, something else. So we're going to talk about these properties more than once, but these properties sometimes make simplifying logarithms easier with or without a calculator. It also is useful when we're solving equations to know these properties. So certain things are always true no matter what the base. And one of them is if you take the log of any base of 1, think about what that's saying. A to the what power equals 1. So no matter what the base is, the answer will always be 0. So you can actually work it out every time, or if you see log of 1, you know it's an exponent of 0. Also is true if you take the log base of a number of that number, like a to the what equals a, it's always just going to be to the first power, right? The other super important properties when we get into solving these equations is the idea that an exponential and a logarithmic functions are inverses of each other. They cancel each other out. So if I have log base a of a to the x power, that's an exponential function, those just cancel each other out. The log a of a cancels out, and you just get x back. Just like when you take the square root of x squared, and you just get x back because they cancel each other out. And the same thing is true as if you have an exponential function raised to the log of that base. So a log of a of x, they cancel out, and you get x back.
You recording?
I am. Even all that conversation I had with Colin about defeating him in life on the recording.
Why do, okay, for log A of 1, why is it 0?
Because if you rewrite it, it's like saying a to the what power equals 1. When what's anything to the 0 power, right? So to get 1 here, the exponent has to be 0.
I thought it was minus sign, and then it was,
No, that's just my blank sign.
I got you.
I could put a y here if it makes you feel better.
I was like, what's there?
And then this one should maybe make sense, the one-to-one property. If you have log a of something equals log a of something else, if these are the same base of a log, do you agree that that means x has to equal y? That makes sense, right? So there's sometimes in an equation that you can do that, and you can just kind of forget about the logs and solve the related equation. When we get into 3, 4, 3, 5, we'll do a whole lot more of these, but I just wanted to give you those right away.
Why is that first part of it? X from exponents to h for log of x. It's an exponent there.
It is an exponent.
And what if it's just x?
one too, right?
I was gonna do that. Use your math room. She went to college.
I can show this one really easy, even though I'm gonna give you. We're in later on in 3-4. We're gonna talk about properties of logarithms, and one property of logarithms is that if you have a logarithm to an exponent, then because a logarithm is just an exponent, you can do the properties that you can pull this out front. If there's a property that says you can pull the exponent out front, and you can rewrite this as x log a of a. And so log a of a is just 1, so that's how we just get x back. I always just say like the log a and the a cancel out, so I just automatically cancel out, pull the x out front. But that's really why it works. I don't have a good explanation on this one. You got me, Oliviero. I'll look it up, okay? I kind of just go with the fact that it cancels out, and I just get x back, but I don't know. I'll think about it. Oh, that's Parker's. This is Parker's after-school snack bag.
Bag of snacks.
Yes, this is his bag of snacks that every day after school he eats something out of it, and then I take it. It's just snacks and a pencil.
Does he only eat one each day?
I have no idea what he eats. Yesterday he ate this whole bag of pancakes. We got home and he said, "Can I have a snack before dinner?" And I was like, "What did you eat after school today?" "Well, you know that bag of Reese cups?" "Yeah." "Well, I gave Marley some and then I ate the rest." "How many did Marley eat?" "Like 2. I said, "You ate the whole bag?" I mean, it wasn't like a full bag, but it was probably like at least 15 little Reese cups in there. And he's like, "Marley ate 2." I was like, "But you ate the rest. No more snacks before dinner." So I kind of don't have any idea what he does after school.
Monitor him.
Mrs. Duvall's child. They're in the same grade, so.
Do not monitor him.
Usually the bell rings at 3:08 and he says, "I'm going to Marley's room." And so he goes and bugs Miss Duvall
And he
until
takes his
3:30.
snack
And he takes his snack with him.
His ball eggs it on.
She's probably like, keep eating the candy. Mom left over eating there.
As long as they're out of my lap.
All right. Just like e is a special exponential function, the inverse of e is a special logarithmic function. Log base e, that's what's going to undo the x function. But instead of writing log base e because e is a special number, we rewrite that as the natural logarithm, which is ln of x, right? Remember ln from last year? I always make my ln a cursive L, even though I don't write cursive that often, because otherwise my L's kind of look like 1s and it gets a little confusing sometimes. So my suggestion if you think you're going to mix up your ln's with your 1s. But ln is just log base e. So when you're doing these properties, it's the same idea. It's just writing it a different way. So if I said ln of 1, that's like saying e to the what equals 1. Oh, look, I got to put y again. And the answer is 0. Thank you, sir. That's fine. And what about homework? Perfect. Did we all caught up? And maybe there's a worksheet that I gave you that you haven't turned in. Not sure. That we were working on the next test.
Yeah,
I think that might be
yeah.
your homework.
Okay. Bless you.
And so ln of e, again, they kind of undo each other, but that's like saying e to the what equals e, and the answer is 1, right? It's like the base, same base. And again, we could do the exponential stuff, the canceling out, or we could think about you can pull this x in front, and ln of e is just 1. So if you see ln of e, it just cancels out, and you get x back. Hooray. And if ln of x equals ln of y, they're both base e, so we can say x equals y. Again, some of these questions are going to be without a calculator, and 8, 9, and 10 are examples of questions that I would never, ever, ever let you use a calculator on a test or a quiz, because there is an ln and an e button on your calculators, which means you can just type it in your calculator and get the answer. So you need to make sure you can check with that, but if you're trying to prepare for a test in here, you need to make sure that you're trying to think about, could you do this without a calculator and get me the exact answer? And then if you want to check on your calculator, you can. But on your homework today, they even say like without a calculator, implying that you shouldn't be using a calculator on these. So the idea is if you can write these as e to some power, then the answer is just the power. All right, that's kind of the idea behind this. So of 1 over e as e to a power. E to the negative 1. And if I have ln of e to the negative 1, then the answer is just negative 1. It's just the exponent because the ln of e are inverses. That's what I mean by do this without a calculator. Next one is 1/2 because the square root of e is the same as e to the 1/2 power. So that's why the answer is 1/2. I should have started with 10. 10 is like the easiest of them all because it's already written as a power, right? The answer to 10 is? You just pull the 3 out. And we'll talk about those properties. All right, so that's how we can do logarithms without a calculator, rewriting it as a definition or using the e stuff. And then I think I just have some calculator ones too, right? Evaluate using a calculator to the nearest thousandth. Again, you should have an ln button on your calculator. If you don't know where it is, ask me and I'll help you look for it. And you just type in my calculators automatically put a parenthesis. I think you need a pass. You need a pass.
No.
Can you try to be the happy column that I used to know before the SFA trip?
I can certainly try, but there's
Colin, you playing baseball?
Yes, sir. Right?
You know what's really
Right?
bad?
Still
Colin has
undecided.
locker
Hey,
decoration up in
you
his
got my
locker.
book play baseball.
They say my name on them, but they put them inside of his locker. They didn't put them on that side, but we put them back on the outside. They put
Because fall sports are over. Is that why?
We're not every day.
Yeah. They put
I don't know,
that
we'll
shit
see.
They love my name.
Yeah, we go.
I got negative 1.609. When I do these in the notes, the idea is that you are practicing using your calculator correctly. What happens when I take the ln of negative 1? You can't take the log of a negative number. ln is a log, right? It's just a special log. So we'll use Grady's undefined answer. Or don't write domain error.
I didn't know that.
So you actually have some time to work, which is good because although this doesn't seem so bad, it's a little tricky. That's what you want. We're not here.
Probably help you out. That's a lot of problems and it's not even honest.
This is 3, day 1. I want you to get your paper out, label this, because I want to look at 1 or 2 of these with you to show you the trickiness.
Slow down.
Yeah, whoa. You're busy talking to Colin instead of finishing the notes. Because I wanted you to do all these. We could change this to all if you want to odds too.
Will you come here for a second?
Hold on, no. I want you to lay down paper so we can do this. And then
I
I'll
did say please, my
Okay, well you have to wait. I'll be back there, I promise. But I'm not ready to come back there because then everyone else is just going to stop doing what I tell them to do. And then aren't doing what I tell them to do anyway.
yeah.
Whoa, you said Grady? Because Grady's already done.
On 2 through 18, it says all the way through 24 to do this without a calculator, which means if you want to check with the calculator, if you have a fancy calculator, then you can check with the calculator. But the idea is these would all be questions that would show up on a no calculator part of a test, or even I could give you a no calculator homework quiz in the near future. Because I want you to be able to do these without a calculator. And if you don't have a fancy calculator, your calculator is not going to help you anyway. Okay?
Like this.
Why are your teacherism so positive and your studentism?
Yeah, that's what I was looking at earlier. I was like, it just makes us bad.
Wait, what?
I know, it should have me, it should have mean teachers because I'm a mean teacher, but most teachers are really positive.
We're gonna have a great year.
Most teachers are super nice, like, hooray, there's not any questions, it's not
No
questions,
talking.
oh. And like, I'm always just like, zip it, sit down.
This is gonna be so fun.
I mean, we need to make my own teachers, and you guys should start a wall of my teachers. Shut it, that's one of my teachers.
I'm proud of you.
But students, you guys really aren't that positive most of the time. Like, in general, there's not, like, when I say, this is fun, you guys are like, this is terrible. And then about, everyone else is doing Halloween stuff for you. And
No one
then I
is
say,
not talking to except for Maddie.
we're doing this. And then you say, well, at least it's fun. It's fun. Not that. This class is never fun. That's
I
my
love you, Maddie.
majority of your homework should be using is this definition. But notice some of them are kind of crazy, like number 6. So I'm going to jump to number 6. So just number 2 and 4, you don't really need a whole lot of paper. You can just do one line.
Oh, you can?
Yes, because it's just a definition. Number 2 and 4 are very easy ones. But look at number 6. It says log base 6 of 1 over the 5th root of 36. Here's what you're trying to do. You're trying to rewrite this as 6 to some power. You're trying to say 6 to the what power equals this number. So what I think you should do, and what I do when I do these problems, think about rewriting this as a power of 6. I can already see some things like 36. Is 36 a power of 6? Yes. When I see a root, what do I know I can do with that?
Put it on the bottom of the section.
It's a fraction, like the square root is 1/2, so the 5th root is
1/5.
1/5. When I see a fraction, what do I have to do to move it up to the top?
Negative.
A negative. We don't have to do that all at once, but those are the steps you're going to have to do in this problem. It's kind of a whole lot of exponent review. So I'm going to show a lot of steps here. If you can do it all at once, by all means do it all at once. But I'm just going to work on this side and work getting 6 to a power. So I'm going to rewrite this as 1 over the 5th root of 6 squared. Can I do that? Because 36 is the same as 6 squared.
2/5.
And then if I'm going to rewrite that as a fraction, kind of a nice review of rational exponents, if you have a root of x to the b, that's exciting, right? That's the same as saying x to the b over a power. Like this is your numerator, this is your denominator. So Grady is right when he says that's the same as 6 to the 2/5 power. But it's in the bottom of the fraction. I need it in the top of the fraction. So what would I do to make that
I thought it was going to be a fire. I did too. Really, right now it's cold.
The school will be burning down. I'm not going outside. It's cold.
This is in the bottom, so to move it up, I'm going to make it negative. So if it helps when you're doing this, like you're trying to make these the same base, because your answer is whatever exponent makes those the same base. So your answer is just negative 2/5. But you have to kind of think through all those exponent rules to get to that point. So some of these are a little tricky like that, so I wanted to make sure we did one together. Not all of them are. Some of them are base 10 stuff, but I still want you to think about doing it without a calculator there, Grady.
I'm checking my answer on number 10.
The E ones, you should be able to think about without a calculator too, because again, all of these are things up until 24, like 26, 28, I don't even know which one I made you go to.
Yes.
But you can use a calculator on those last two.
So if it doesn't state the base, we just assume it's base 10.
It is always base 10 if they don't say the base. Okay, now I can answer your question. Wait, I need to stop recording. Have I given you guys assignment sheets?